You're about to listen to a conversation that I've had with David Snowdon. He's a successful entrepreneur who started a company and sold it, also studied computing at university and was also involved in the UNSW solar racing team like I was, albeit at different periods. Dave is a true nerd in the absolute greatest sense of the word. He has an absolute passion for technology. He's really interested in people, and I was always so interested in understanding how someone who started university being so interested in computers as a fundamental ended up essentially running and successfully growing a business. We talked about what computing was like in the 80s and the 90s and 2000s, what high frequency trading is and why it's useful and how he could carve his edge into that world. I first heard about Dave when I was 20 years old, and he was actually one of the organizers for the solar car event that he used to be part of and I was now part of. If you don't have much time and you only want to hear parts of this conversation, you can jump to specific points in the video or look in the description for the timestamps. I've had so many questions for him and our common past, and I finally got a chance to have a chat to him. I guess my first question for you would be, you know, it's been a very long journey from what I can tell, like 20 plus years in the world of computing. And where did it actually start for you? Like I got interested in computers when I was probably like 14, for instance, kind of in high school or mid to late high school. Was software something you always knew you were going to study at university, or did that not really come up until like year 12 when you were choosing your university or whatever you were going to do after high school?
I was really interested in computers from a very young age. There was this psychology professor at the university my dad worked at, and he was the dad of one of the kids in my class, and we were good buddies. And he was using computers as part of his psychology research. And basically they had a mini computer. He was basically that person who, you know, a bunch of people knows that sort of opened my eyes to the fact that computers even existed. And they were upgrading to a Mac sometime in the mid 80s, and they were getting rid of their Apple IIc, so my dad bought it off them. And we used to play computer games on this thing. It was like Raftaway River and a bunch of other...
What period? Is this like 85 or something?
Probably like 88, I would guess.
Was this like the height of Apple too, kind of thing? Or had they kind of started to wane at that point?
I mean, the Mac had been out for a few years and people were starting to upgrade to the Mac. But I mean, the Apple II, we had new Apple IIs at my primary school in the late 80s, maybe even early 90s. Like,
so this is before people had computers at home. Most people didn't have
most
computers
people,
at home.
yeah. Like, but people, I know other people around us had computers. They were mostly being used for computer games. People had Commodore 64s and Ataris. The Nintendo came out, and that was amazing. These consoles became a thing. People had IBM PCs, and there was definitely the Windows versus Apple thing going on at that time, but Apple meant either a Mac or an Apple II. So, it was clear that the Mac was the next, was going to be the thing.
And when you got this Apple II at home, you got to play with it a bunch. Like, did you have pretty free reign on it a lot of the time?
Oh, well, Dad wanted to stay ahead. Like, he wanted to make sure that he stayed in lockstep with the kids. And at some, like, he would let us like plug in. He got a mouse with this thing, and he wouldn't let us plug in the mouse because he didn't want to not learn as fast as the kids. And at some point, it just must have become obvious that we were going to spend all of our waking hours, understanding this thing and trying to play with it. And we went off and did a whole bunch of things.
Was it mostly video games you were playing on it? Like, what did you do with it?
Yeah, we had video games, and then my parents they went to Hawaii. I think that must have been later. It was about 1988, something like that. And they went to Hawaii when they knew I was really into computers. And when they came back, they gave me this book, and it was like, it's called How to Train Your Basic Kid or something like that. It's an Apple II book, but it's written like a storybook, and it's about BASIC, the programming language.
They had kids books for
kids
BASIC
books around,
in the 80s.
There was Aunt Tilly. She was the narrator of the book, and then the wizard was the guy you went to when you really needed to understand something complicated like peek and poke, which is basically like pointer dereferencing in BASIC. So yeah. It was this really super weird book. And then the other thing that happened was the computer broke at some point. I can't remember what happened. And we went to this we went to this repair shop, and we were talking to the repair guy, and the repair guy said, we were talking about how I was interested in the computer, how it worked, and BASIC and so on. And he had this giant stack of magazines that were called Nibble magazine. A nibble is half a byte. And he gave us these magazines. And these magazines have listings for programs. So literally the source code for computer programs are stored and are listed out in these books. And you would type it in. You'd hope like heck that you didn't make a typing mistake, because editing things, going back and changing anything at that point was actually really quite annoying.
Well, you say quite annoying. I mean, when I make a mistake in my code, I change.
Well, you press the up button, right? And you go up, delete.
Yeah.
Right. That's not how the editor on the Apple II worked. You go re-enter the line. So you go 10, print, whatever. And if you wanted to print something else, you would have to retype the whole line again. Yeah. Like the editor was not good. I mean, that might be my amateur experience of the Apple II, and maybe there were amazing editors that I just wasn't aware of. I'm sure Vi existed and all this sort of thing, but not, and these were floppy disks, 5.25-inch floppy disks and everything, so 5.5, whatever it was.
That's amazing. I mean, that's incredible that you kind of got inspired by that in primary school. Was that was just pretty consistent through high school, I imagine, if you went and studied computing at university?
Yeah, like I was pretty interested, always playing around. I mean, it became, I was one of the early users of what I used to log on to bulletin boards in about, year 7 or 8 or something like this. I mean, back, online, all the dangers around kids being online just weren't such a big, they weren't such a thing back then. So there was bulletin boards. Used to go to meetups for the bulletin boards. This is not pre-internet, but pre-popularization of the internet in the sort of early 90s. And then, but you used to chat people on there, and they were generally computer professionals or other kids or whatever. Used to download programs. We only had one phone line at home, and what would happen every now and then, Mum and Dad would pick up the phone and interrupt my connection. I would have been downloading some 50 kilobyte file for like half an hour, and then someone would pick up the phone and then interrupt my 50k download. And I'd be like, "What are you doing? How could?" Yeah, I mean, there were various times. My dad is a doctor, and he was on call on various occasions, and of course this phone line was busy, and so they really needed to get through to him for various reasons. And I was on there, and eventually we got a second phone line so that we could hook the modem up to it without a. But this was a big deal, and then of course the internet came along during the mid 90s. So yeah, it was good. There was a good group of people at school. There was a librarian at school who was very, very, very good to all of us. There was the AV department at school, like all the AV, I guess it was a bit of an attraction for us quirky types who would all end up hanging out in the AV department because they had the most powerful computer in the school. Yeah. And we used to do a lot of that. And so there was a lot of fun applications. Now it would seem trivial to most people, but we were, at the time it was hard to do these things.
Yeah, for sure. It's nearly romantic to think about that kind of, past where it's this kind of cute, cutting edge hobby. And you obviously went and studied at university with computing too. And like one question I had there is, and I teach at the university now, and I've taught for a while, and computing is really commoditized now. Like you go talk to first years and stuff, it's this kind of, maybe a little less now in 2025, but the last few years, big booming tech industry, Google, Microsoft, Atlassian, Canva, it's this big kind of app-heavy corporate giant type of world. And it's like, that's the psyche most people come to study in, is they think it's a great industry to get into that university can move them into. And I know that wasn't the case for me even back in 2012 when I started. It was much more around, I'm interested in this and there's probably cool things I can do with it. Not a lot of people were ever talking about salaries. That was like never a conversation. Was that also the case when you started uni, I imagine, in the late 90s, or was it even different further?
Yeah, I think computing has gone through various waves of popularity during my time. When I was a kid at school, being a computer nerd was most uncool. Yeah. Like that was that was not seen as something that, it was seen as you had it was like stamp collecting or something. Like it was just an unproductive waste of time. Why would you bother like playing with, you're spending all your time playing on computers. I mean, if you've ever seen like war games or something like this, and like, it's just, and you felt like you had to you were a computer nerd in spite of that. Like you had to be really passionate in order to want to, like it was a detriment. You didn't become a computer nerd because it was cool. You became a computer nerd because you were interested in it, and you did it even though it wasn't cool. You had to fight against the system. And then like at university, when I started, Microsoft was a thing. Like Apple was a thing. People knew who Steve Jobs and Bill Gates were. Like these were the kind of...
So you kind of saw the popularization of it between the time you first...
Well, they were the pin-up boys of our era. Like this is what you could become.
Bill Gates, richest man in the world.
But it wasn't something that would happen locally. That was just something that happened over in Silicon Valley or in Seattle. Like it was all very remote.
Yeah.
And here in Australia, it was, I don't know, I didn't feel like this was an option that was available to me or something that I aspired to. Although like other people at the time did, and they had the vision to go and power away at that. I was at university in the same year as like Mike Cannon-Brookes and Scott Farquhar and these guys, and they clearly saw a huge opportunities, but I felt like we're all destined to be little cogs in a big machine, and we would work away in our little place here in Australia and go forward. And that's obviously changed very significantly, as you point out. Now you go and all of these options are seen as being available. You can go to university here and you can really have a huge impact, a global impact. And I think, there's a lot of reasons for that. And one of them is that those guys I just mentioned have gone and created a huge company from Australia, a huge company with global impact. There's various other huge companies with global impact that have been created from Australia, but none quite so visible or have had such a huge effect on a large number of people's wealth. You could go into computing for the money and hope that it's gonna and work away at that and have that ambition if that was what you were interested in. But I tend to think that if you did that, you wouldn't you wouldn't have the interest that would carry you through, and maybe it's just that you wouldn't have the interest to carry you through to actually having the impact that you want to have. So I think it's gone like in mid school, ICQ. I don't know if you even know what this is. It was one of the first messenger apps. IRC obviously, but ICQ was kind of like an MSN Messenger, then came out after that, and like all these messaging apps. And then kind of this is the early days of probably what's become social media, where people would log on to. After school, I'd go home and log on with my 2400 baud modem, and I'd send messages on ICQ to my friends, and we would chat away. That's where I got fast at typing, because I wanted to be able to talk to my friends in real time and stuff like that. So there's this like social aspect, and there was this number of people who were super interested there. And then the other big thing that changed was getting together with large groups of people that were interested in the same sorts of things, and having that center of gravity, and making me realize that, not that computing was cool, but that there were other people who shared my interest. And so like going to the National Youth Science Forum was a big deal start of year 12. And then later on, joining up and carrying those friendships through university, and that gave me a big social group here. And like
I was going to say,
that was huge.
Yeah, it must have been so nice coming to university, and particularly being part of the science forum, because I imagine through high school, as you said, it was a bit of a dorky exercise, and the majority of your cohort in high school in the 90s are going to not be interested in computers, and then suddenly you're at university and you're just surrounded by people who
are.
Yeah, I mean, you're studying the thing. That must have been such a...
It was awesome.
Yeah, breath
so
of
great.
relief. Yeah,
it was so great. Yeah, I mean, and it started at the start of year 12 with this National Youth Science Forum thing, which is 200 or 300 students in. I went down to Canberra, and it was a similar experience where there was a whole bunch of people who were both socially active and like able to talk to people, but also interested in the same things that I was interested in. So you had this sort of eclectic group of people that are still some of my best friends today.
Oh, that's amazing. And like you start university as a tinkerer, kind of engineering software kind of, nerd in all the positive sense of the word. And then, 15 years in the future, you're obviously a business owner, essentially. And I guess my question is, at any point during those first years of university, would you have ever imagined yourself as a business owner? Were you there in second year being like, I might start a business one day? Or were you just very like, I love the tech, I love the tinkering, and that was who you were?
Yeah, I wasn't thinking about the business side of it, but when I think back on it, I was probably right the way through there. I was picking up various tools that were that I was sort of adding to my arsenal of tools that were later to be used in business. Well, like, I mean, the solar cars, the first sort of big thing. I joined up literally in O Week in first year. They had a stall on the walkway, and they were showing off the solar car. I think they might have even had the solar car out there. They'd just come back from a big trip from Perth, and they'd had a lot of media attention from that, and I'd seen that, so I was super excited about this. Went down to the workshops, and they the project manager at the time was called Chris Tucker, and he told us all about it. And I got super excited about this. But what I really liked about, now that I look back at it, is that I again had agency to get things done myself. Like, I was given projects and I just worked on those, and I worked autonomously on them, and just learned a huge amount by working with my hands. And there wasn't a lot of software around a solar car at that point. We didn't have really digital systems. The motor controller, all analog systems for the most part, maybe with a few ICs, but they weren't the sort of complex software systems that they would be today. Yeah. So that, I guess when I look back on it, like joining up the solar car team was my first real exposure to a group of people trying to achieve a goal, and organizing themselves to be able to do that with all of the different pieces effectively that fit into a business long term. And I think that solar car experience was formative. So
I mean, I think obviously you and I are familiar with solar cars. I think just for the regular person listening, I mean, is it fair to say a summary of a solar car is basically like a multi-wheel car? It's not a bicycle. They had 3 or 4 wheels. They tried to have as much solar panels on the roof of the car as you could, and car is a very loose word to describe what was essentially like a flat rectangular object with wheels that you kind of sat in as little.
Yeah, in those days even more flat. The regulations have changed. So I mean, the solar cars was really a car built to compete in the World Solar Challenge, which is an event that goes from Darwin down to Adelaide, 1,000 kilometers. And the cars are designed to be powered by nothing but the sun and a small battery. So this team was building a car to compete in that event. And at the time, they'd competed in one event before that, in the 1996 World Solar Challenge. The 98 World Solar Challenge had been cancelled and moved to 99. And so they were preparing for the 99 World Solar Challenge. And
were you in your first year when?
First year, yeah. Okay. So my first year was 99. Yeah. And it was awesome. They were keeping the same solar car. They were building a new solar array for their solar car. They'd all learned things during that time. They had they'd for the 96 event, they'd acquired a old solar car from an old solar car team called Aurora. And they had given them all this junk, basically, like maximum PowerPoint trackers, like all sorts of stuff. And I thought I'd never been involved. My parents aren't particularly handy, or my grandfather was, but we didn't really do big hardcore projects at home or anything like that. So this was my first exposure to people who were like, I don't know, grinding metal even, or anything like this.
So you basically took part in like putting in your, volunteering your time for free, like everyone else in the team does, to work at trying to build, optimize, function this solar car that students build. And then every 2 years, take it on a big race where you drive the whole thing up to Darwin from Sydney, and then you drive it to Adelaide, and then you drag it home. How many of these races did you enter in the end, if it was every 2 years?
Geez, a lot. I went on so I guess the other thing to realize is that, we weren't successful in all these events. Yeah. I'll get back to the number in a second. We weren't successful in all these events. Like the 99 event, there was smoke pouring out of the top of the car on the start line, and the dean of engineering was there, and we were all like super embarrassed, and but we had done it ourselves, right? Like this was entirely student run, entirely student organized. There were I think we had there was a person involved from the TAFE who Ken, he was there. But for the most part, there was being taken care of by the fourth years. Yeah. And they were like, the adults in the
big
room.
Adults, yeah. The
Right.
21-year-olds. Or
Exactly, yeah. And so you felt this incredible sense of freedom in that you weren't being told what to do. You were all figuring it out together, even though the fourth years really seemed to know everything at that point. We had all these failures. So I was involved in the 99 event, and I think we came 18th out of 40 teams or something there. The 2001 event, we did a huge amount of work. We really gave it a good go. We built our own, there was a group of people who built their own solar cells. We came up with some novel encapsulation techniques for encapsulating solar panels on curved surfaces.
Is that basically like, what does encapsulation mean? Is that like laminating the solar cells? As if you fed it,
Someone built like this 4-ton vacuum chamber with a mold built into it. So it was like we could draw a vacuum on the shape of the car. Like it was serious industry. Like even looking back on it now, it's serious industry. Like a serious amount of effort. And not to mention the fact they built their own solar cells. They had a team of 20 or 30 students that were in the PV labs here at UNSW. They built a simplified design, and we got over 20% efficient solar cells, which at the time was astounding. There's a bunch of other issues that come along with that, and probably the biggest issue is like none of it was tested. This is an academic project rather than an industrial project, and in an academic project, well, it's good enough for it to work once, whereas for a product or in industry, it's not good enough for it to work once. It's got to work every single time, and this is very true in a solar car event where it has to work on the start line.
Thousands of kilometers in the desert.
Well, there's only one race, right?
Yeah, sure.
So if you stuff up on the start line, that's another 2 years until the next event. And so I did this. We stuffed up every single time. There was always something.
Like 2001 something.
2001, there were shorts inside this beautiful solar panel. The encapsulation
More
technique.
Smoke?
Sorry?
More smoke?
I think there was smoke on various occasions, yeah. But I mean, so there was that. There was in 2003, there was an incident on the way to the event and the solar car got damaged. 2005, the suspension wasn't particularly great and we had an incident there. 2007, I was at an internship at Intel, so I wasn't part of that, but I came down as an observer. 2009, we finally got my what I would call my one like really good event. It was still like heartache along the way, but 2009 we finally got one.
This is a random fact of trivia, but I think years ago, maybe 7 years ago, I read your 2009 race debrief.
Oh, really?
I think you would have written. And I don't remember anything from reading it except that you'd referred to it as your one good race. And nearly as if you couldn't quite let it go.
I couldn't, no. I mean, my PhD supervisor would,
because you were into your PhD by 2000.
Oh yeah, I mean, I started my PhD in 2003 and went through to 2009, and I only really probably took that long because I was working so much on the solar cars rather than on the PhD. Yeah, my supervisor was most upset at all this, but on the flip side, I learned a huge amount along the way by doing all this, and not least of all by failing repeatedly over and over and over. Every single time you think this is going to be, we get it this time. And
I think it's hard when you know what you can accomplish too, right? Because like each of those times that there was a failure, you have that sense that you were 99% there, and that the team is like a lot of capable people in it, and you just have to get a few more things right, I imagine.
Yeah, it's interesting. On all the times when we didn't get it right, it felt there was a lot of stress within the team, and I guess when it's not going right, it's harder to be happy and harder to be relaxed than when it is. And I think
it's hard when you're doing it for free too, and you work hard, and then not that like people are financially motivated, but it's a lot to give up for the end result at the end, right? Like, because you're spending dozens of hours.
Yeah, I was just working on things that I was interested in at that point, and like footloose and fancy free, and just didn't care. Figured if I wanted to make money, I would make money later. That would be fine.
You said before, like when you started, there were all these fourth years there, you know, and like if we've raced forward to 2009, it's been 10 years since you started university.
Yeah.
You're now like a 10th year there. By the end of this journey, were you kind of like the wise elder of the team?
Oh yeah. And to start within the 2008, 2009, that cycle, I just came in as someone who could effectively be a source of knowledge and point them in the right direction. And I just enjoyed myself so much talking to these guys, and they seemed to be able to tolerate me being involved. So, we built up a good partnership there, and I think it ended up much for the better. And out of that group of people, I still have very, very good friends that I hang around with and catch up with and all the rest of it. So I feel like I mentored a bunch of them, and later on, even after I stopped working on the solar car, during that 2008, 2009 period, people would work on their fourth year theses, and I would mentor them and supervise them and so on. So that was, I think it worked out well.
That's amazing. And like, because obviously I've been part of these teams too, and there's a lot to do. So what did you actually get up to in that period? Like, obviously if you're a software guy and you became computer electronics, you weren't going and like designing suspension systems or steering columns or anything like that, I imagine.
I didn't design a suspension system or steering column. I did do a lot of work with carbon fiber, and I designed various bits and pieces. I didn't do the CAD for it, but I worked with people doing the CAD. I would always be a source of ideas.
Did that come from your experience a bit? Like if you've been on multiple races, by that point people must tap into you just for your general experience with solar cars.
Yeah, absolutely. And I got fascinated with it, working out how we could package things, how the mechanical systems could be better built. This wasn't really coming from my university education, but from my solar car education.
Yep.
I'd seen enough solar cars and seen how it's done and read enough books on it and really sunk into it. So it was all, I wouldn't say I'm a mechanical engineer by any stretch of the imagination, but I think I can critique some of the designs and see some of the trade-offs and have the conversation with a mechanical engineer. And then when we had this 0809 event, there's some fantastic mechanical engineers that came and worked with us. And, I was able to bounce ideas off them, and we were able to sort of help each other out. And I was able to have that kind of cohesive view of, and maybe this is a theme that comes up later, but the cohesive view of where the optimization needs to be made. There's this idea that you could build a mechanical system or an electric system, or you could make a trade-off with the way you build something. And I was able to probably provide some insight as to how those trade-offs should be made and where the appropriate balance could be, both in any aspect of it, whether it was the business side or the organizational side or the logistics or any of the other aspects of building a car and taking it to Darwin and
because
down a highway.
What I don't want people to forget either is, it's not just a bunch of ragtag kids building a solar car. This team at various points, they go and do visits at schools, and they go and make posters, and they go and bring in sponsorship money and sponsorship material. Like, these teams at various points have been dozens and dozens of people like working very hard. So I imagine there's quite a lot of different types of people you got to work with.
Yeah, absolutely. And I mean, that's a good point, that there are lots of different types of people that you meet, especially over that kind of period of time, people cycling through. And as my role changed through that whole period, learning how to interact with people in a way that ends up being productive. I can't say I'll ever master it, but it's a continual learning experience. And I certainly learned a huge amount during that 10 years worth of going from being very junior to being the old wise hound.
If you had to pick across that whole 10 years, an absolute high point and an absolute low point.
Oh, man. Well, I mean, I think the absolute high point was really that feeling of getting into Adelaide.
At the end of the 3,000 kilometers, the full race.
At the end of the 3,000 kilometers, yeah. And we'd had various high points along the way, and it started to become obvious that we were going to do okay.
Yeah.
We had a pretty rough first day, and I thought, oh my goodness, this is just going to be the same thing over again. And then, but by the end of it, we had won our class.
Yeah.
We were in the production class using silicon solar cells, and every team that was in front of us had a $2 million solar array, and we had a $30,000 solar array or something like that. So it started to become more and more apparent that it was going to be okay. It also became apparent that, my software work and all the work I'd put into strategy and so forth was working, and that we weren't, all the fears that I had. So there was this great sense of relief getting in. So I think that would be, you couldn't go past that.
Yeah.
I mean, there's so many other high points that you could talk about along the way, but
just to unpack, you made this comment about strategy. And I think before I joined the team, when someone said strategy, I had this image in my head of business strategy. But, strategy in the context of a solar car team is mostly how to effectively win the race, which is often, understanding how the car performs, and it's understanding the right speeds to do to get the most out of it. And tell me if this is wrong, but when I explain it to people, when they're like, what is strategy on a solar car race? I'm like, it's basically the same team of people who, when you're in an electric car and you punch in, I want to drive to Melbourne, or Canberra is a good example because you could do that in one charge. It's got to give an estimate of how much battery you'll have when you get there, based on its understanding of the car, how the car works, the hills you're going to go up, what's going on with all that. Is that a fair summary of what strategy is? Or do you think that's a bit
in the context of a solar car, it's even more interesting because you've got a small battery, so you can go any speed you want to for a short period of time. And
how big was the battery in
5
those solar
kilowatt
cars?
hours.
Right, it's about 10 to 20 times less than an EV kind of thing.
Yeah.
Yep.
Yeah. So it's small.
Tiny.
It was enough to drive about. Because the car's so light, you can drive a lot further on it.
Yep.
So than you would be able to in
How
a
much
normal
does
EV.
the car
So
weigh?
it was about 200 kilos.
200 kilos, right. So you could carry the car away.
Changed depending on which year it was. But it could probably drive about 300 kilometers on the battery, but you have to drive 3,000 kilometers.
And that's taking in power from the sun as well.
No, you'd be drive on the 300 kilometers on the
300
battery
kilometers just on a little tiny battery. Yeah, sure.
That's
Wow.
right. Because the cars are designed to be so efficient.
Yeah.
But so you can drive very fast. You can go 110, 120, 130 kilometers an hour if you want to, but the battery won't last very long. And in a solar car, it's really interesting because the slower you go, the longer the event takes to run. So the more energy you actually gather from the sun because you're spending more time gathering energy. So strategy in that situation is really, how fast should I go right now? And how fast am I going to? I mean, that's the output to the team and to the driver. It's like we want to drive the car at 82.3 kilometers an hour at the moment, and we're effectively running a control loop that is designed to minimize the amount of time that the event's going to take. And you can go as simple or as complex as you want in order to try to optimize that, but it has a very, very significant effect on the outcome of the event. And the biggest effect it has is if you run out of battery at any point, you have to stop. So you have to avoid running out of battery.
If you go too slow, you lose, and if you go too fast, you run out of battery. Is that?
Yeah, I mean, if you go 0.1 kilometers an hour, you never get there. So there's some lower limit to how fast you can go and still complete the event.
And it's not just a math problem, because there's a lot that can go wrong in real time too, right? Like you might be like, I figured it out. We're going to do exactly 79 kilometers an hour today. That's the perfect speed. And then you come up behind a car doing 74.
Yeah, and this is a great lesson because not everything is perfect in the world. You can come up with the best academic solution to a problem and then get completely stuffed by some real world event. And then that happens in everything, right? Like another interesting thing about solar car design is that you can design a very, very fast solar car that actually goes very slow during the event. And the reason is because you over-optimize for the theoretical. For example, you have a very low aspect ratio on make a very thin solar car, and it just doesn't perform very well. The Stanford guys in 2009, designed this incredibly thin solar car. Like they decided that as a substitute for performance, they'd just like make the car really, really thin and decide that would make them as aerodynamic as possible. But of course, any kind of pitch up or pitch down on a really thin aerofoil like that means that it's not running in the best theoretically optimal circumstances. And so like it just performed terribly. And the same was true of like all sorts of different situations in solar cars. So you can come up with the absolute best strategy, like absolutely amazing. You've sat there and you've iterated on it forever. And then, I don't know, someone puts a bit of tape on the solar car and laminar flow gets tripped to turbulent and your aerodynamic performance goes through the floor, and now you're using way more energy than you expect, and you need to be able to adapt to that.
I was talking to the current solar car team, because the team's obviously still running since 1996, and I think last year or something they were telling me they're running all these big AI machine learning clusters to figure out optimal stuff, and I was like, that's cool, that's the point of the team, go learn some stuff. But I remember I said to them too, I was like, you got to remember that most of that will get thrown out on the day probably, and you need to be very comfortable having an intuitive understanding of the physics of it, because you're going to have to make a big back of the envelope decision sometimes, fairly quickly to get the team going.
Yeah, and with that, there was we had this event where we didn't get to Darwin, and a friend of mine and we headed up to Darwin and hung out up there. And then we caught a ride with one of the teams down, and the team we caught a ride with was Aurora. And the guy who was running the team, his name's Peter Pudney, and he'd actually done a PhD on solar car strategy. And as he's doing this, everything was just so calm. And so, like, the events that I'd been involved in had all been fraught, and people were stressed out and running around. But everything was just, we're gonna go to 95%. We're not gonna try to push to 100. We're not gonna optimize everything to the nth degree, because we need room. We need to keep the team calm. We need that little bit of capacity to absorb, things that go wrong. And one of the things he does, that his PhD developed, was the way you plan out the strategy is based on battery state of charge. So as long as you can, and you do it in a way that you can measure it. So integrated current is one way of measuring battery state of charge.
That when you say state of charge, that's like the battery percent.
How much energy you got sitting in the battery, like how full the battery is, 70%, 50%, whatever. So he would plan out what the state of charge should be at every point in terms of distance along the event. And that strategy would get updated over time, but it doesn't change very much. If you go too fast, then your battery state of charge drops, and so you slow down. And even though you don't try and stick to the speed that your model suggested you were going to do. You stick to the battery state of charge for the distance through the event. And it means that the model is resilient to things that go wrong. If you stop, your battery state of charge at that point in time goes up, and so you have more state of charge. You can go faster afterwards.
So that gives you a real quick ability to just make decisions and be like, well, we knew at this point we should have had 78% battery, but we have 80. So if someone wants to overtake another car, you're like, well, we have a little bit of...
You've got a bit of room.
Yeah.
Sure. And you probably want to go a little bit faster than the model's telling you, because say you have a tailwind. If you have a tailwind, then your energy use in the car is going to go down. And so you can probably afford to drive a little bit faster. Well, you can afford to drive a little bit faster. And your model, that will quickly adapt in the model if you're looking at battery state of charge whereas if your model was spitting out speed and you were slavishly, trying to stay at the speed, and your battery state of charge would be increasing because you would be using less energy at that speed than you had expected to. Conversely, if you have a headwind, you're now going to be using more energy than you expected. Or if you have a crosswind and you just have this completely unexpected, you don't know what the aerodynamics of the car are going to do while you have this horrible crosswind. Or if the tires are scrubbing, or if you have a tire is leaking or something like this and the pressure is going down, your model has to be able to adapt. But what Peter's model of the world did was encapsulate all of that, and you would boil everything down to something that you could measure very easily on the fly, and that was a light bulb moment for me. So I think that's the other thing that I picked up along the way here, is just this ability to listen to mentors and look at other people's work and go, yeah, that's a great idea.
I love you talking about these inspiring moments, like when you're with Aurora. So like you're with another team basically, or you're seeing the cool things they do. And it's funny because we talked about highs and lows, but some of my highs of all my years in solar car, one of them was actually when I went and volunteered in the South African race. I went over there for a year in 2016, and one of the days I was put with the Delft team, who are basically like, at least for the last 15, they're kind of like top tier kind of team. And it was so exciting being with them for a day, particularly on the starting line, because I thought we were pretty cool, like our solar car team. But I remember this moment, they were driving down this road and they missed a left turn. There's a lot of turns in the South African race. And as soon as they missed this left turn, they pulled the solar car over. They commanded like 2 words on the radio, 2 vehicles of like 4 people. So 8 people got out of their car. They marched to the solar car. They knew exactly who stood where on the solar car. They, 3, 2, 1 in Dutch. They pick it up. They walk it across the highway while twisting. And then they plant it back down on the other side of the road because it was quicker than trying to figure it out. And they're back in the car. And the whole thing took about probably 25 seconds. And that's, funnily enough, some of my favorite moments. Wasn't necessarily something I'd accomplished, but like a eureka moment of like, someone's just brought this incredible idea to me that I'd never had before. And it gets you inspired because you're like, there's so much more to learn, basically.
Yeah, it gives you a lot of energy when you see these people who are coming up with great solutions to problems that exist.
Yeah, like even the state of charge thing you mentioned to me, and as someone who did strategy on a race, I'm sitting there going, that's very smart. That would have made life a lot easier. So you did strategy in the later years, but I also know you did a ton of stuff with the electronics. And I guess it's like, if you started uni as a software guy, to be oversimplified, how did you make that drift into like, and I think just again for people listening, like electronics, computer engineering is still a lot of software, but you're not writing kind of code for apps and stuff as much as you're trying to program how like a digital. So, I mean, how would you even explain it to someone who doesn't know anything about computer electronics?
I think computer engineering is kind of like a combination of hardware and software and building computer-based systems. There's so many computer-based systems in our lives, especially now, that they're just ubiquitous. So, yeah, a computer engineer is probably a little more low level than a computer scientist would generally be. So
a good example for me is like, we know in lots of modern cars, there's like tablets, and I'd imagine the person who works on, Apple CarPlay and stuff, they're quite your stock standard kind of application software engineer. But then when I think of computer engineering, I think about the engineer who knows some software and electronics, who, when the driver presses the accelerator pedal, that's got to turn a little piece of hardware that's going to send a signal through some circuits, which is going to send some signal through some other circuits. And that's kind of what you spend a lot of time on.
Yeah, building sort of ubiquitous systems like that, or like the window controller on your car. Yeah. It's probably, in a modern car anyway, is probably sending a message down a network that's telling the little motor in the window to go up and down. Or your steering wheel has... So, I mean, those sort of embedded systems are... they're involved. When I first started out, there weren't mobile phones, and this idea of having a portable computer was just astounding. And I remember some guys at the university had built this board based on the SA1100, which is the same processor that was in the Newton. It's an ARM, and they were running Linux on it, and they were walking around and like running Linux, or they had they SSH'd into it and ran X11 apps, and I'm like, my mind was blown that this was possible.
Just the idea of a computer that you could walk around with.
Yeah, this is not like a real computer. Yeah, like that's insane. I mean, we had laptops, but we didn't have like handheld size type devices. And the idea that you could run a real operating system, and which was effectively a real computer running on a processor that you could lift was totally weird. I mean, the iPhone moment was in 2007, so there's 8 years before the iPhone was announced, and there was so much going on, and none more so than within the research group that I was part of for my PhD at that point.
Well, I mean, speaking of that, obviously you did your undergrad, and then you and then you said you spent like 6 years doing your PhD. Like, what was that in? The only thing I really have heard about it is that it is a computer electronics or a computer engineering type of PhD.
Yeah. So, I mean, I did my 4th year undergrad thesis on the solar car, of course. And that was on... really, up until that point, we'd had mostly analog systems. I'd done a bunch of like wiring potentiometers into circuits to control the speed of the car. Would be this like variable resistor, so like seriously old school technology. And in 2002, I built a new system based on a network and a series of microcontrollers, so little tiny computers that are sitting inside the car. I had got them all talking to each other, acting as sensors, operating things like the indicators, but also operating things like sending the speed commands over the network.
What's the motivation for? I mean, again, as someone who's not an electrical engineer, why would you want to move from an analog system to a digital system? Is it more flexibility? Is it lighter? Like, what's the real benefit?
Probably the major benefit was that we could get much better information about everything that was going on in the car back to...
So sensors were a big deal.
Yeah, and you would do this in a kind of a ambient way. You would do it without having to really put extra sensors into the car. Up to that point, we'd had this big data logger, which would have literally analog wires running out to various places in the car with analog sensors, voltages going back to this data logger, which would then send us, samples, and literally had relays which would click through the different sensors so that it could sense all this stuff. And then we changed over to using like microcontroller-based systems, and it all happened pretty quickly. We changed to using, we'd had maximum power point trackers, which are basically the circuits which control solar panels. We'd had those in 2001, and they had a microcontroller on them. So I built a connection for that microcontroller that allowed us to pull the data out of it. And later on, we used, then rewrote that software to get a little bit smarter and make use of information that's on the network to do other things.
That's such an interesting change for me, because if you fast forward to 2017, because I was involved with the team from 2014 to 18, in 2017, things are so digital and we're so comfortable with that obviously the solar car's sending, digital data back to the chase car who's following behind it, which isn't new by that point. But we'd set up a little Raspberry Pi in the car that was running a web server, and then I'd stuck a tablet up on the windscreen, which was running a web app talking to that web server. So me driving the chase car could actually see the car's speed and their gear and things like that. And that was super useful for us because, the experience, the solar car radio's over and they're like, the car's not working. And without even having to talk to telemetry, you could see some really basic stuff there. And it's crazy to me to think that that's all built on kind of these levels of digital infrastructure that before that were just people messing around with wires and switches, and you wouldn't have had that.
We didn't have any, like when I said we didn't have any software in the car, like there was no software in the car that we were using. Like, there's nothing. Because
how do you tell if a motor's too hot? That's like there's like a wire with a heat sensor, and the hotter it gets, the higher the voltage is, and that would go back.
No, the car just stopped, and you would go in and go, "What's going on?" And you'd like try to work out and go, "Oh, the motor's too hot."
Yeah.
There was, because there was a sense wire going from the motor back up to the motor controller, but there was no digital communication with the motor controller. There's no real reason, no way. There were a few LEDs on the front of these old motor controllers. But it's interesting talking about that because at the same time, this is the same time as we were the first customers for a company called Tritium. And we emailed these guys, one of the guys on the team, Jamie, he emailed up to one of the guys on the old University of Queensland team and said, "Hey, you guys had pretty awesome motor controllers during the last event. Can we get in on that? And so they said, yeah, we've got a bunch of our old controllers that we built for the last event, but we could build you a way better one. And so this group of people got together and started building a motor controller for us. And they brought it on the 2000.
This is an Australian startup that was doing this, yeah.
Yeah, but they were doing their PhD. Dave Finn was doing his PhD at the time, and James Kennedy, he was working at, I think, IntelliDesign at the time, and they were just sort of doing this as their side project. And they built this motor controller in Dave's basement. So Dave was doing like some PhD on multi-phase switching converters. So he was, sidebar, like power electronics is a total black art, and most of what he says I don't understand. But, like, it's just astounding. Anyway.
No, on that sidebar, like, I get that because, and again, I'm not an elect guy, but there's kind of like that world of electronics that you're in. And then there's this world of power, which is people who, work on the grid and, things like that. And then there was this magical world in the middle called power electronics, which, as I understood it, was like, people who understand all the stuff, but they're doing it to like do really complicated power applications and deliver things. And I, to this day, still think it's possibly the most confusing subfield of engineering that I've...
And it doesn't feel like it should be, like if you've got a motor, you basically need to shove current through the motor one way or the other, depending on where the magnets are relative to the windings.
Yeah.
And that's all it needs to do, right? Like, how hard can it be? And on the surface of it, sure, like, this is not very difficult. And I bet there's a whole ton of people in solar car teams worldwide who have tried to design their own motor controllers. And, as soon as they plug them in and try to get them working, they'll probably get them working for, a few revolutions of the motor, and then it'll blow up.
Yeah.
And then they'll go, well, why did it just blow up? And the art of power electronics isn't in, getting it to work at all. It's getting it to work efficiently and reliably. Like, it's really hard. Like, designing an antenna, it's the same sort of thing. Like, you can design an antenna, it's like a bit of wire, no problem. But to get it to actually capture a large amount of signal is difficult. And again, it's another black art. And having an appreciation for these people who can conduct the black art basically is, I definitely got that out of this whole solar car thing was great. So 2002, I transformed the solar car from an analog system to a digital system at UNSW. There's nothing particularly innovative there, but a bunch of people had done this sort of thing before, and certainly high-end cars at that point were operating on local area networks. But I did it for us, and I came up with a protocol. And I think even you guys, that many years later, were still using a bunch of my code, at the core of the network. So I'm proud of that. Like, there was some longevity to it.
Yeah, the team used to look at circuit boards with your name on it, and be like, magic.
Who's that dude?
Yeah, they didn't want to touch it. No, it's interesting, even what I learned about engineering, because it took the team, I think, maybe 2 full years of like what was essentially 4 days a week of work until they felt like it was actually going to be helpful to design their own thing. And, seeing them be like, oh, no, we don't want to touch this because this is someone else's years of experience expressed in hardware, and we're just like second or third years who don't know enough yet. I always thought that was interesting.
Yeah, I mean, there's pluses and minuses to that, though, right? I mean, I know that in other solar car teams, they deliberately redesign everything from scratch to challenge all of the assumptions, because it's very easy to create sacred cows out of things that shouldn't be sacred. And
yeah.
It's very easy to assume that someone really cared about every decision that they made when they were designing something when probably weren't. They probably just like did something fairly arbitrary at the time because it was good enough, or they were in a rush or whatever. And then some way later, there's this archaeological experience trying to decipher what someone previously has created. So there's this argument for like totally recreating everything every time, and then there's this argument the opposite way. It's like if it ain't broke, don't fix it. And one of the things that moving to a digital system, did was modularize the whole system. So you could plug things in, unplug things. add things in and out, and that really became a way that we could move a lot faster by updating small pieces of the system rather than designing the system as a whole. And I think that was massively valuable, because previously when you had the analog system, you couldn't change anything, right? Like if you wanted to have a temperature sensor, you had to have a set of screws to connect that temperature sensor in.
Yeah. So a good example is like, I think at one point, I spent 3 months in the team actually. I think I wired most of the 2017 car myself. Not because I knew anything about electronics, but because all the elect guys, I was like, you go do the hard work. We're short on hands. I'll go and plug in everything and, tie it all down. And it's interesting you say that, because, yeah, that would be the case. Is the rear brake lights, for instance, just LEDs. We would just hook them up to a little, piece of electronics, and that would connect to the network of the car. And as soon as that was on the network of the car, it was just, a low-level software engineer, right, who just was able to then say, oh, well, when I sense someone press the brake, turn these lights on. And there wasn't you didn't have to go change anything on the braking system. And that's what you are talking about with modular stuff, right?
Yeah, or if you wanted to add in an extra PowerPoint tracker or an extra solar panel, or if you needed 2 motors instead of 1, there was all sorts of, if you needed extra sensors or anything really, like we added in a battery monitoring system. Like adding a battery monitoring system didn't require any modification to the rest of the car. You had this abstraction of the network, and by creating nice abstract interfaces between these modules, you're able to just really run fast. Whereas previously the whole system had been designed as a whole, and that was then challenging to make any kind of modification to, or make, to really innovate. So providing ourselves the infrastructure there to be able to innovate long term was super useful. And it bore out over the next bunch of years, right? It was 2009 by the time I was really done with it. And at that point, I had sort of refined, a bunch of the stuff that we had in 2002.
If I had to ask one overarching kind of, dramatic question about solar cars, it would be, do you think we'll see solar cars on our roads in any mass-produced capacity?
We've already got solar cars on our roads, and they're all mass-produced. I think the right place for solar panels is pointing at the sun, generating as much energy as they can, and there's plenty of space for them to do that while not sitting on 4 wheels. So the best place for your solar panels, if you're going to buy a bunch of solar panels, isn't on top of your car and sitting on your garage roof pointing at the sun. And then thanks to the magic of the grid, we can share energy between various sources and various sinks. When you need energy, you grab it from the grid, and when you have extra energy from your solar panels, you give it back to the grid. We're able to all share. And I think that's really then becomes an interesting problem of how do we make sure that, the generation and loads kind of line up, that most people want to be able to charge their cars at about the same time as everybody is generating energy. Anyway, back to your point, I think solar cars exist. They're already there. Tesla really came out of a period of time in solar car racing.
Well, their original CTO was from Stanford solar car team, I think.
Yeah, I think he was on the team or associated with the team.
Yeah.
And certainly a bunch of the first employees were on the team. They'd just been part of the American Solar Challenge.
Mm.
I think in Ashley Vance's book they talk about this. That they were sitting around on his floor trying to talk about everything. But really what happened was in the 99 events, American and World Solar Challenge, everybody flipped over to using lithium-ion batteries, and it became very, very apparent that this was the dominant, this was the technology of choice. So there were a whole bunch of people then that knew how to build lithium-ion packs, knew the quirks, and the Tesla folk then went and really built the battery pack as a real product and worked out the quirks and worked out how to use it properly. And they realized that they had a useful amount of energy for driving a real car. Went on to the Tesla Roadster and all that.
Yeah. I was always shocked how deep-rooted Tesla was in the solar car community. Even back in 2015, which is before 99% of Australians had heard of Tesla, Tesla had flown full-time employees to Adelaide, I believe, at the end of the race. And they were kind of mingling around and, you know, being like...
This is well and truly into Tesla. I mean, I had a Tesla at that point.
Yeah. You're one of the early owners of it.
I think we had one of the first 20 or something. We got, you know...
Was it really expensive back then?
I mean, about the same as it is now.
Yeah, okay.
Yeah, but I mean, you're buying a Model S at that point rather than a Model 3. So it was it was designed to compete with a Mercedes.
Yeah.
And it had Mercedes like components all through it and things like it. That was what it was designed to be. It wasn't designed to be kind of a cheap car. It was designed to be a posh car. And like, interesting, the technology adoption that they went for. They went for the high-end sports car that cost like $200K plus. And they had like built 2,000 of those and worked out how, you know, a bunch of kinks there. But at each stage they got feedback as to how to, you know, they went for the high-end sports car, then the luxury car, which is the one I got. And then they got, you know, went and introduced the Model 3, and then they diversified out from the Model 3 out to the Model Y and so forth. So done pretty well right the way through, right?
I have this memory, it must be nearly 8 years old now, of you making a Facebook post. It must have been talking about your car driving on the M2, like semi-autonomously or something like that.
Oh, right, okay.
And I always loved, because, you know, you obviously bought one of these really early on, and I thought it spoke really clearly to your passion for technology. You know,
I had to have one. Like, I mean, it was a silly financial move, but like, I mean, imagine if I'd put it into your company and it would have just accumulated wealth over like
Yeah, but like, you weren't the type of person to be like, I'm going to go get this, you know, luxury car because, you know, I want to be posh and I want to be, it was so cutting edge.
It was because it was the first practical electric car. So my wife drives, at that time drove me, 100-kilometer round trip, so it was to work, so it should be 50 kilometers each way. And if you were to buy a Nissan Leaf, you would have to recharge after every drive, and that wasn't practical. We actually didn't have off-street parking, so we couldn't charge at home, so it wasn't practical to do that trip. So once the Model S came out, she could do 3 trips to work and then charge, and it turned out that they were putting a supercharger in at their showroom in North Sydney, so she could supercharge on the way. And that worked out brilliant. And at that time, you got free supercharging for the car as well. So you bought the car and then your driving was free. Again, silly financial. None of this makes sense, but, you know, it was all of a sudden practical to drive an electric car. And this was like, these are the cars I'd been working on for 10 years. Yeah. In fact, because the solar cars are just electric cars. Yeah. Design, a little bit weird design for an event, but like the power electronics and all the rest of it are...
The fundamental concepts are pretty... Yeah, most of it's just a
battery motor. In our case, we had solar panels, but the Tesla doesn't have solar panels. It has a charger.
So after 2009, before you gotten the Tesla, you'd started a company, as far as I understand it. What?
Well, there was I had there's an interim step where I moved into finance.
Okay.
Yeah. So, and it
what kind of finance?
It tickled my my interest in optimization.
Okay.
Right, trying to build engineering systems that work to be as efficient as possible. So I got into at the end of my PhD, one of my buddies there asked if I wanted to come work at the company he was working at, and they were a trading company. So they buy and sell shares, and it's a high frequency trading company. So they're buying, selling shares intraday. Very, very frequently, so millions of contracts a day.
So these are very powerful computers that trade on the stock market to try and make money?
Yeah.
And how do they make money by trading on the stock market? Is it just like they predict what's going to happen and they try and get ahead of it, essentially?
I mean, that describes every trader ever.
Yeah, okay.
Doesn't matter who you are.
Whether you're buying houses or you're... Yeah, exactly. Okay.
Try to say, okay, I'm going to buy
They're buying
Microsoft,
and selling stuff. Yeah.
Buy low, sell high. It's very simple.
Yeah,
right?
okay. Yeah.
I mean, in your case, it's buy low, and I know that the market is generally going to go up over time, so I can sell high, and so there's very low risk. In this case, they're buying a large number of contracts where the probability of them going up in the near term is very small. So maybe you've got a 50.1% chance of the contract going up in the near term or going down, and 49.9% are going down. But there's that edge where, on average, it will go up over very slightly.
And that's made possible with computers, because 20 years prior to that, you couldn't have real human traders who are taking 50.1% bets because just the volume would be too much.
Right. But you did have day traders.
Yeah,
They effectively did the same job.
Just at a lower volume, essentially.
Lower volume and with larger margins.
Yeah,
so
sure.
They couldn't take a 50.1 because you couldn't do enough trades to really make any difference. But what it meant was that you could take much greater risks for each individual trade, but because you got so many trades that it averages out.
Just before we go deeper into this, because it's kind of going to be a bit of the common theme throughout your business a little bit, is this kind of high frequency trading. And, if you kind of talk to a normal person, they think about computers making trades on the stock market. I think there can be a certain amount of like negativity to that in terms of like, that's not really producing anything, you're not actually helping society. But I know there's necessities to those kinds of businesses too. And it's like, what is the aspect of this high frequency trading world that the world would be a bit, lacking without?
I mean, the way to think about HFT in particular is a little bit like the day traders of yesteryear. You had a whole bunch of people who were all yelling orders at each other, trying to buy low, sell high intraday. So you buy some options or equities or whatever it happens to be, and you sell them later in the day because they're going to go up. You think they're underpriced now, so you buy them and then they go up and you sell them and everybody's happy, and you just do that over and over and over and over again. The day traders are doing a very important job, which is providing liquidity into the market. So that means if you're someone who purchases stock or some product every now and then, you have someone to trade with. They're putting orders in both sides, both buying and selling all the time. And so if you want to sell something, they will buy it. And if you want to buy something, so the way to consider HFT and day trading is really as part of the plumbing of the market. They're the thing that creates the market. By having enough people in there buying and selling all the time, you're able to have a pool of liquidity which allows you to do it. What they're really doing is trying to set the price, so calculating out what the actual price of these are, and by narrowing down the spread of buy and sell because you've added liquidity in, you basically reduce the amount you have to do to jump that spread.
Yeah.
So if you want to sell, and the spread is like where I'd say the spread is the difference between the buy and sell price. If you want to sell, then you've got to jump to the buy price, and if those two are a long way apart because there's no one who's really in the market who's creating accurate prices, you don't. So what the traders have done then is over the years has gotten more and more and more and more better and better and better at pricing different instruments in the market. So whether it's Apple stock or whether it's like options or whatever it happens to be, they've got better and better and better and better at coming up with a price that reflects the buy and sell price. And by doing that, they've brought the spread close together. Effectively, they're kind of paid by the market to set the price and to set it accurately and set it in a way that reflects the wider market opinion. So
like I obviously have this, long-term investing company, and, I might log in and I might try and buy $1,000 of an ETF. An ETF, you think of it like a stock, and the problem is without any day traders, without any high frequency trading or anything like that, if I go to try and buy $1,000 of a stock, there has to be another citizen out there who's wanting to sell a stock at that time, and that both of us are happy to buy and sell it at the same price, for instance, like a market order. And when you talk about the plumbing of the market that, these day traders provide, they largely ensure that, when I want to buy something or sell something, that there's probably, particularly for the higher, volume
because
stuff.
The exchange doesn't provide that. I don't know that that's something that a wider group of people really understand, is that all the exchange is doing is providing a venue to match buyers and sellers. It's not providing a facility where they will buy a stock off you and then hand it on to someone else at a later point in time who wants to buy it off them.
It's like real estate agents don't buy your house from you.
Right. So, I mean, that's the job of the traders, and in particular, this group of traders called market makers. And in fact, they end up getting paid by the exchange to provide liquidity. So the exchange will give rebates often to market makers in order to incentivize them to provide liquidity, so that when you want to go and buy 1,000 ETF shares?
It's index fund.
Yeah, but what's a unit of an ETF? It's a share, isn't it?
Yeah, that's the name. I understood ETF meant exchange traded fund, but then years later I was like, that actually makes sense because it's a fund that's just traded on the exchange and has a unit to it.
So they basically form part of the plumbing of the market. They're the way that shares get from A to B, and you should consider them to be part of the market. They're not the people who are trading based on value necessarily. Yeah. They're the people who are shoving things from A to B, and they paid a small fee each time. So
they keep the market, being able to always deal with buys and sells, and in return they make a little bit of money, basically.
Yeah, and then of course to do that, I should point out there's nefarious players in anytime there's a huge amount of money here, and you're going to get some interesting characters
greed and all this kind of
exactly
stuff,
so but for the most part that group of people are a fantastic bunch. Like the people that I've come across are
and this was like a startup you were part of that was dabbling in
so
this.
They were a proprietary trading firm, so they're trading there only. And they were I won't give away like what their strategies were, but they were trading a lot, a very, very large proportion of one of the Asian markets, and providing a lot of liquidity in particular instruments. And they were, doing that by using automated trading techniques and high frequency trading techniques.
Right. And this got your interest in optimization, essentially.
Yeah, it was super fun. Like, because my role was really to make things faster, and make, optimize the trading firm's operations. And there were a lot of other really smart people there. One of the cool things about trading is there's enough money around, and the financial incentives are right to be able to hire really great people. And if you were to say anything negative about the trading industry, that's probably the biggest negative that you could say, is that it's taking a huge number of really smart people and putting them to work on this problem, which is important to society, but maybe not as important as curing cancer or climate change or any of these other things. You're taking a bunch of... On the flip side, it's a really interesting problem. And if you had said to me that I was going to get into finance when I joined up at UNSW in '99, I would have said, you're absolutely crazy. I couldn't think of anything worse. And it turns out that this is actually just a really interesting problem with a great bunch of people working on it. And it also, like I said, it tickled that idea of optimization. I think you want to be able to build systems that work as optimally as possible within a rule book, even when things go wrong, like we were talking about. So it had a lot in common with solar car strategy, really.
And how long did you work there for?
I think about 18 months.
Yeah.
Yeah.
Was that the interim step before you started your own gig?
Oh, there was another interim step, which was, the story goes that the founder of one of the founders of that trading firm, he decided he didn't want to do that anymore, and he started his own company. And sometime later, I followed him into that new company, and that was then providing. The original purpose of the company was to set up a third exchange in Australia.
Like a third stock exchange?
Yeah.
Right.
Yeah. Chi-X had just come in, and so the regulatory pathways for having multiple exchanges had been blazed. They have 13 at that time, now 14, I think, in New York, and we thought that there was room for it. But the focus of it would be to build a technology-driven exchange. None of this is my idea. And so he started doing that. I went forward and started building some of the technology to back up this exchange. And I got really interested in exchange fairness, being very precise about delivering packets, like the messages which carry information from the exchange, like buys and sells and prices and all this, making sure that they were delivered at exactly the same time to all the participants in the market. And most people would think that this is, about being closer or further away from the exchange, but actually all the fibers in an exchange, the optic fibers which carry this information, they're all cut to the same length. So whether you're on one side of the data center or the other, just doesn't make any difference. You really start to, and particularly now as things have moved on, you start to come up against the speed of light, and this, unfortunately, for the most part, the speed of light is a constant.
I'm just trying to understand this well better, because I've watched YouTube videos on this stuff, like those 15-minute educational stuff, and it's like the exchange is like the New York Stock Exchange or the ASX or like the New York Stock Exchange, an easy one. They have fiber optic cables, super high-speed communication cables that go to companies that trade on the stock exchange. Is that how that works? All these market makers and traders?
Yeah. So, I mean...
Because they want that information quickly, because then they're not acting behind the 8 ball, right?
Yeah, I guess we didn't really cover that. So a stock exchange now is just a computer.
Yeah.
It's a computer with a data structure sitting in it that says, here's all the buy and sells. You've got this double-sided order book, which is put in. It used to be sitting on a blackboard at the front of the trading hall, or whatever it was. Yeah. Now it's in memory in some computer or on a disk in some computer somewhere. And those computers sit in data centers, generally, so big halls of computers, which are, presumably power protected, like lots of different sources of power and
backup generators.
The exchanges are interesting because they have to be very interesting systems, because they have to be quite reliable. They're critical infrastructure. So there's backup data centers also, and they have a lot of work goes into making sure that these things are fairly bulletproof. So in the old days, if you were to talk to an exchange, you're on a normal trading floor, there was this whole market in Chicago of high-heeled shoes for men. And it would be because you would be more visible sitting on, like, if you were taller, you would be more visible. So there was this, like, you had shoes that were like super tall, like platform sort of thing for men, so that, because the traders were men. So that they could sit there and yell out to the front of the floor their orders, and they would get better visibility and better reliability in their execution if they could do that. There began a market, began to be a thing as the digitization of the exchanges happened, that people would like to get physically closer, because the speed of light is in fiber, it's about 5 nanoseconds per meter. In air, it's about 3 nanoseconds per meter. So the closer you can get to an exchange, and these are meaningful, like this sounds like a really tiny amount of time, but for a computer, a few nanoseconds is a real amount of time. You think about a 3 gigahertz computer, that's 3 cycles per nanosecond. So in 5 nanoseconds, you get 15 cycles in a computer, and so
a cycle is like adding 2 numbers.
Yeah, like an instruction. And in modern computers, there's multiple things at the same time. You get superscale computers.
If I just try and understand like the value of being close, like tell me if this is a bad example, but like, let's say I'm someone who I'm trying to trade homes, like buy and sell homes, right? And my job is to understand the price of a home, because, if there's a home out there that's a little cheaper than I think it is worth, then I want to buy that really quickly so I can sell it again to someone once everyone else figures out what it's worth. And it's like, I'm interested in getting the most up-to-date information before everyone else, essentially. And is that of a similar thread to like with these, trading companies? They want to make sure that they're always...
They want to make sure they're at no disadvantage. Generally they'll want to either have an advantage or at least have no disadvantage compared with their peers.
Yeah. So otherwise people are beating them to make decisions.
So even if you have a 100 nanosecond advantage, then you have enough time and you're doing exactly the same calculation to work out whether you want to buy or sell a particular stock. Say like a notice comes out from the exchange, these quotes come out from the exchange saying that someone has just entered an order into the exchange saying, I want to sell Apple at some price. And everybody knows from their internal models that is going to make you money for sure. It's a fire sale because someone needs to dump their stock for whatever reason. And you're like, I am on that. You want to be the first person on and you imagine that this happens for equities a little bit, but when you go to an options market and there's so many instruments, there's so much mispricing, you've got a very strong relationship between the underlying, and I mean, people listening probably won't have a good understanding of what an option and a future is, but basically these are derivative contracts and they're used to manage risk for all sorts of different purposes. So they have real world uses. Originally the futures exchanges, for example, are like, I will purchase your corn at the end of this growing season, and I will make the promise on what the price is going to be now. And that's effectively transferring your risk to me, and I will pay less than I would otherwise pay if everything else goes accordingly, because I need to price lower because I need to pricing in the risk. But effectively you transfer the risk over to me as to whether it's a good growing season or a bad growing season.
And if the corn price goes way up, then it's like you won out.
Then I won out, but if it goes way down, then I could afford it cheaper.
Yeah.
And I've accepted that risk. And that's useful for the grower of the corn, because they now don't have to worry about selling their corn in 12 months' time. They don't have to worry whether it's a good season or a bad season.
This is what I see on the evening news where they're like, iron ore futures are up or something. That's people who are placing bets on the price of iron ore in the future.
Yeah, exactly. And because there's lots of different people placing bets, and I don't know if bet is the right word, but they're effectively predicting what the price will be in the future and then attempting to make money out of that. There's quite a lot of science to that. And there's like Nobel Prizes that have been won, the mathematics behind predicting these derivatives, like the models for the way derivatives behave and so on. So there's a lot of hardcore math and engineering in how to very precisely calculate how the prices should behave. What that means is that there's very simple models that if, for example, a new option price comes along and it doesn't match the model, high or low, you know whether you can sell or buy that option, high or low. And by selling or buying it, you know that it's going to correct itself at some point in the near future to the model. Either the model is all going to shift, or which would be unlikely, or the thing. Another one would be a new piece of information comes out about the underlying, the price of corn, for example, because as the price of corn goes up, it becomes more likely the price of corn in the future will be high. So the price of corn affects the price of the value of the futures. And so when the price comes in, everything gets repriced. All of a sudden there's a big...
Because I could sell my future to someone else.
Yeah.
At a higher
price.
Because
they're all tradable. So you've promised to buy XYZ corn from 10 barrels of corn from the farmer, but you could sell that right to buy the corn to someone else. And so if your prediction on what the future value of corn is different to someone else's prediction, then there's a mispricing and you can sell it. So all of this is going on all the time in the markets as a fundamental part of the way we stabilize the prices of all sorts of different things, because we can trade the risk, and it gives everybody information about which way the price on something is going to go. So you get basically crowdsourcing. If you imagine it as kind of like crowdsourcing what the future price of something is going to be, is have all these different people trading on it. And the more liquidity, the more people who are having opinion on what that price should be, the better idea of what the closer it's going to be to reality. And as to your point earlier, as things change, if there's like some giant storm that comes through and wipes out a whole bunch of cornfields, now the price of the futures is going to change dramatically, because there's going to be less supply in the future. So now you go, okay, it's just repriced. The people who own those futures can sell them if they don't need the corn, but equally they've insulated themselves from the risk of the corn, and they can buy the corn off the farmer in the future. So
that makes sense. So like after your kind of these interim jobs, is it fair to say that you then didn't kind of get into business to, write algorithms to predict the future of corn or anything like that? You were focused on building electronics to provide...
We were selling access to the gold miners.
Okay.
So, and this is what my boss at the first job, he left and started this company to build the exchange, but he also started a firm to provide technology to the exchange. So we started working on that technology to basically deliver messages out to a large number of people simultaneously and quickly, and then gather information back from all the participants in the market back to the exchange, and do that in a fair and fast way. So you were selling to
exchanges?
We were selling to one exchange, so we basically created our own customer.
Yeah.
Now, all of this fell apart because the first company was very unhappy that the second company was ever started. Okay. And probably won't get into the legal details.
So it was the third exchange trying to get set up.
was more about the technology. So they were unhappy that the guy had left and started the new company.
Oh,
and
okay.
They then had a very big argument about pretty much everything. But it included IP, it included solicitation, it included fiduciary duty and various other bits and pieces. And I then got, was part of all of that. And
you're just trying to build cool stuff.
I had to be on the exactly right. I got on the stand and had to be a witness, and I never ever want to have to go. That is a horrible experience. But the upshot was that company shut down, and they were put out of business, and some bits of IP were transferred to the previous company as compensation for the wrongdoings. I don't know. I won't have an opinion on which way I'll get myself into trouble, but basically they transferred some bits of IP to the first company that I'd worked at.
Yep.
And then the second company held on to some other bits in IP. But those bits of IP weren't enough to be able to keep that company going. So that company was shut down and everybody was let go. And I happened to be in Chicago at the time because I also was putting on a different hat of starting to do sales. And we chatted to someone in Chicago who at one of the trading firms over there. And he was like, well, we were chatting to him. I was saying, look, sorry, we can't deliver these products because, we just got shut down and that's not cool.
So you're working for a business doing sales in Chicago and it's all just wrapping up.
It all wrapped up at that point. And then we were basically over there to say sorry. And they just said, he walked out of the room and went and got someone and said, hey, I just want you to tell this other guy about it. And the other guy turned out to be just starting out their VC. And this was really the genesis of what became Metamako, which is the company that I helped found.
Metamako came out of the dying ashes of a previous company that was saved by like a venture capitalist who's someone that basically has a bunch of money and was willing to take a bet on what you guys were doing.
They were willing to take a bet, but they were also willing to go through the motions of insulating, going through the legal processes to make sure that what we were doing, we were okay to do. And we were more careful about making sure that we were allowed to do what we were doing than any startup ever. It was so paranoid. We thought we were so scared. But at the same time, we thought this was really great technology and we thought we could do something special. So we formed, got a bunch of the team that had been together at the first company, at the company that was put out of business. It was called Zeptonics. And we got them together, and that became the core team a subset of them became the core team at Metamako. I mean, Zeptonics had been doing all sorts of different things, and we just sat down and wanted.
That must have been exciting. I mean, it sounds like years of turbulence, and then eventually getting to this point where it's like, okay, we've got a team, we're VC backed. Let's go build some stuff.
Yeah, I mean, we were VC backed, but it was effectively a stressed sale in that there was so much likelihood of legal action, and we'd just come out of this court case, and we just thought, just didn't know what was going to happen. So
my lawyer friend says to me, anyone who wants to go to court has never been to court.
Yeah, that sounds about right. Yeah, like I said, I came out of, I was just a witness, and I wasn't getting sued, and I came out shaking. It was not an experience I really want to repeat. Hopefully not again. So we were very careful to make sure that we were not just doing the right thing, but able to show that we were doing the right thing.
So from there, was it just go build this hardware? Like, what year was this when you guys really settled into this company?
This is 2013.
2013.
Yeah.
Right. And then how many years from 2013 until when you ended up selling the company?
We sold in 2018, so 5 and a bit.
So for those 5 and a bit years, was it basically just you were designing hardware and manufacturing hardware and selling?
Well, my role really changed a lot over that period of time. When I started I was very much the jack of all trades.
The Sunswift guy, the solar car guy.
Yeah, exactly, right? Yeah, exactly. So I started out by working on various bits of infrastructure that I thought would help the rest of the team. So I ended up doing a lot of work on things like build systems, which are bits of software which build software. And then we extended that out to also building logic. And this was one of the key advantages that our company had over a period of time, was that we could provide high quality while still being quite agile. And that was really because of the build systems that we were able to. So I think that was, and I've since talked to other CTOs at very large companies, and it's a similar thing, that you end up working on the infrastructure to be able to enable the rest of the engineering team. So I was working on that. I did things like help make layout changes to the circuit boards. I built schematics. I did a lot of the speccing of the original designs. I did a lot of sort of architecture work to spec out how the products should be and be built and put together.
I just want to understand, like, exactly, like, when I think about you built, as far as I understand, it's like high frequency switches or like high speed switches. And it's like, I know that at home I have a wireless router. I know that the internet comes in and it can send Ethernet out to different computers. When I think about, what you were up to, I'm like, well, is it just that with a lot more plugs in it for more computers and it's just really quick? But then what does that mean? Because like my computer at home seems pretty quick, like quick enough. Like what's the core?
You got to remember, it's not human timescales we're talking
yeah.
about. Like, we're talking about computer.
But like, what's fundamentally wrong with like a network switch or a router you can buy?
The state of the art at the time was a like an Arista 7150. Was the particular product, and it had a chipset from a company called Fulcrum, and it had about we talk about latency, which is the delay through one of these devices. It had a latency of, I think it was something like 400 nanoseconds.
So that means from the time a signal comes in to the time it gets sent out to the right spot on the other end.
Yeah.
There's like 400 nanoseconds of time.
400 nanoseconds, or so 400 billionths of a second.
Yeah, and what you're saying is, like, to a human, you couldn't notice.
No, absolutely not.
Millions of nanoseconds, or maybe whatever
you probably millions of nanoseconds is reasonable to not be able to notice. Like, you wouldn't notice milliseconds.
So you're talking about like something that's tens of thousands, maybe 100,000 times smaller than the scale of time you can notice. And the reason this had to be quicker was because people you were selling it to, that 400 nanoseconds mattered to them. Back to the exchange and the speed of the cables.
Yeah, absolutely. And it's not even necessarily about each individual packet, but on average, if you're slightly faster than everybody else, then you will execute better more often, and you'll be more successful in your trading if you're going for the obvious deals. So if some obvious deal shows itself and you go, yep, I'll have that, it's a game of snap, and you don't have to be much faster in order to you just have to be faster than everybody else. So if your software is the same, that's making the trading decisions, is the same speed as everybody else's, and your switches are 400 nanoseconds faster. Remember, you got 2 trips through this, like at least 2 trips, once in each direction. Then you do better. You make more money. So we were doing this. Basically, what we wanted to do was be able to, if you imagine an exchange provides you with 2 optical fibers, one that light comes out of, and that's got all of your trading signals on it. Who's just put what orders into the market. It's called market data. And then the other is the one that you place your orders on. You say, you put light into it in order to say, I want to buy Apple, I want to sell Apple, whatever it is.
Yeah. So Like, that makes sense to me, because I think people can understand, you want your computers to be quick, but it's not just computers in some problems, it's also the network
well, it's
pieces.
basically like when that light comes out of that, so if that fiber is sitting at the top of the rack in the data center and there's 65 meters worth of fiber that then goes to a switch on the other end, and it's this exchange's job to make that as fair as possible. And that's a whole nother conversation about reverse engineering the guts of exchanges to optimize your trading patterns to avoid bad times for trading. Like, there's so much complexity inside the exchanges themselves, and exchange fairness is like a bit of a passion project of mine. But that if you have that fiber coming out, if you want more than one computer attached to that fiber, and at the time there were usually exchange rules saying that you had to have a switch there, but you could in theory directly connect a computer to that fiber.
And then make all the decisions on that computer.
On that one
computer.
There's no network. So there's no
network
at all. And you make the fiber as short as possible from the computer. But that wasn't generally done at that time. And you generally have to pay per fiber to the exchange. So the exchange will charge you something large, like 10 grand a month, to be connected to that fiber. So you generally want to share that fiber amongst a number of computers. But you also want to be able to do things like monitor what's going on that fiber. So you'd like to be able to see a copy of the traffic that's going in each direction, a copy of the messages that are going in each direction. You want to monitor that, and you'd like to timestamp it so you can very precisely measure what your latency was, for example, or what time the packets come in, so that you can then run simulations later. Yeah. So you would put a switch there, which would allow you to connect lots of computers to that one fiber. Bit like your home router allows your computers around your house, lots of computers, to talk to the one internet connection. It's the same sort of thing where you have lots of your trading computers want to be able to talk to the one fiber. And then there were like layers of redundancy, so you'd have like fibers and backup fibers, and the switch would be able to switch between them automatically and things like this using all sorts of fancy protocols like BGP.
And so it makes sense. I kind of get the problem, and you got to build some hardware to make it happen. I kind of have two fundamental questions. It's like, how? Like in the simplest terms possible, how did you make it faster?
Well, the thing about trading that I think was an insight we had was that you could build a specific device designed for that one job that would be much better for that one job than anything. It built a specialist tool that was designed to pass packets through really quickly. The product that was the best product on the market had been really designed for data centers, so the likes of Google and so forth, where what they're trying to do is serve as many web pages per second as they can. And that's really about the volume of traffic, the number of transactions per second. But it's how many transactions per second you can do. It's not how long each one of those individual transactions takes. So it's a very different optimization when you get down to the nuts and bolts of it. You want to, for the likes of serving web pages and services, you want to have things like caches, and you want a pipeline basically, because you want to get throughput. Whereas pipelines, which is where you break a job up into a number of small jobs and do each of those small jobs effectively, but do them all really fast. That will hurt your latency, because you'll end up taking longer to do each individual job, even though you can do more jobs in total per second, because you've broken it all down. Whereas what we wanted to do was design a very specific device which did exactly what it needed to and nothing else. The other advantage you've got in the case of an exchange or in case of trading is where the packets are going. A lot of the complexity of a traditional network switch is in choosing which port where the next packet is going to go, whether it needs to go, which computer it needs to go, particularly in a data center setting. And so we can cut all that complexity out. So we built the simplest, most silly, least intelligent switch we possibly could, but we made it incredibly quick. And what that really meant for us was using layer 1 switching in order to replicate the bits. We didn't even inspect the bits. We didn't even decode them. We had no idea what we were passing through. All we do was take that feed, that light that was coming from the exchange, and replicate convert it to a electronic signal. We'd replicate it, and then that would allow us to route it around to the ports that it needed to go to, and then we'd replicate it to all of the rest of to a bunch of other ports, and that would allow us to view what was going on that upstream port. And then likewise for aggregating back into the exchange, you don't need to look at the packet particularly. You don't need to know where, like, you don't need to look at the address on the front of the packet in order to know where it's going to go. You can just cut all of that and just aggregate straight back into the exchange. And by cutting out all the smarts in Switch, we're able to really, finely tune that round trip. So you go through the switch on the way down, that would take 5 nanoseconds instead of 400. And on the way back in, I think our first iteration on aggregation was something like 100 nanoseconds. So we'd cut out 700 nanoseconds roughly of the 800 nanoseconds round trip time. And for traders, this was game changing. And this took over the market. The top traders were using this pretty much as soon as we brought it out.
Are they companies like Optiva and stuff?
I won't name
customers,
but
sorry, is it companies like Optiva? Yeah, for sure. And I mean, it's funny because, obviously the stories, someone builds a company, builds a product, manages to sell the company one day. But, I've learned from my own experiences, like everything, it wasn't just 5 years of like, everything's just getting better and better and better. And now someone's buying us. Like there must have been, I imagine, at least one difficult period during that where either like you were like, this isn't what we think's going to work, or you hit a ceiling, or a competitor comes in. Like, what were the really scary parts where back then you were like, this might not even work out?
One of the biggest things was when that original company, that high frequency trading firm that I worked for, they had some of the IP from Zeptonics.
Yeah, when it was split up between.
Yeah. And so they started their own company to productize that.
Yeah.
And so now we had a competitor that, we were all thinking the same way because we'd all worked together.
So this was like some of the colleagues from that original company were at company A, and
all of that actually, there were various people who had worked here at UNSW in the research group here. We'd all worked on our PhDs together, so we had sort of the same operating system installed. We also thought about problems in a very, very similar way. And we were all working up in the, within 2 or 3 blocks of each other in the Sydney CBD. So we were creating the future of finance, in parallel, together in there. So we, so that was probably one of the biggest scary things. I mean, we eventually, basically both signed an agreement that we were going to cross-license all the IP, and we just wanted to get on with it and compete because our customers started to ask questions about whether we were going to go sue each other and that sort of stuff. So it was quite relieving at that point to be able to move forward. I mean, the investor that we had is a company called DRW, and they're a very large high-frequency trading firm. There's the VC arm of the customer we had. So they're a very large high-frequency trading firm. Actually, they're high-frequency, medium-frequency. They invest in real estate and all sorts of things as well. But they were just fantastic to work with. But they were also a strategic investor in that they were very keen to use our product and were giving us lots of feedback on how to make it better. And they had the incredible foresight to not require any special treatment from us, which is, I mean, to think about it, you would be so tempted as a trading firm to say, okay, we've just invested in you. You have to give us your best technology, and then you can give it to everybody else 6 months later or something like that. And they didn't do that because they knew that it would kill the company. We'd never be able to sell anything to anyone. But
probably does better for them in the long run too, right?
I think if
you're a successful company.
Yeah, they were keen to see the products exist rather than gain any particular advantage out of them. They wanted to be on the bleeding edge.
They didn't want to have a disadvantage though, back to what you said, right? So they were just like, we just want to make sure we're treated like everyone else.
Right. So one of the big insights we got from them was we'd had this before, but was the importance of timestamping and measurement. And this comes back actually from the research group, where benchmarking and testing and measurement becomes such a core part of everything you do. You can't possibly understand your engineering without testing. So we ended up building the subsequent products that we built were very precise timestamping machines. And or sort of network switches with very precise timestamping built in. And we ended up getting that timestamping after a period of time down to sort of 15 picosecond resolution or something like this. And to put that in context, 1 bit on a 10 gigabit Ethernet signal is about 100 picoseconds wide.
Is picosecond smaller than nanosecond?
Yeah, it's a thousandth of a nanosecond. So if you want to have a low number of if your response time is in the low number of nanoseconds, you really need to be measuring in picoseconds, because you need to be able to not just understand what your response time is, but the distribution of your response time.
Also, if like your network switch is taking 100 nanoseconds, if you aren't measuring in picoseconds, then you've got like a 1% error already, right? Yeah. So you need to go that level deeper.
But when we first started, like the timestamping devices we had were like plus minus 7 nanoseconds. And remember, we were building 5 nanosecond switches. So already the resolution of our timestamping equipment was greater. The error in our timestamp, you get plus or minus 7 nanoseconds. We had to average over a very large number of packets, and then like do tricks like use different file lengths in order to calibrate the timestamping devices and things like this. So it mattered a lot. And this was the same conversation that I would have with the customers, because I took on the sales role. Well, at least the technical sales role, until we got real salespeople. And we'd go out to the customers and say, look, we've got this really accurate timestamping device. And they're like, yeah, we don't need it anywhere near that accurate. And I'm like, just try it. Just give me, and they would give it a go. And all of a sudden they'd realize that there was a level of detail that they were never able to see until we were able to provide them with a very precise device. The other thing was that at the time, when we first started out, timestamping was done on like accurate timestamping with hardware was done on like 1 or 2 ports. You would maybe timestamp your incoming exchange, your market data feed from the exchange, and maybe you would timestamp an outgoing feed. And DRW had built this device called NetRaptor, which they've written about, which had lots of interfaces, and they had built some infrastructure around it. And they were the only ones who were really doing doing it en masse. So we built this device which had 48 ports, and everybody was like, we don't need to timestamp all that. I'm like, just give it a go. It took some time convincing these people that they should. And what they discover is they get one of these devices and then they just start adding ports to it. And they go, this is really handy. Now I can see everything simultaneously. Don't just timestamp my exchange feed, but I timestamp both sides of the switch. And remember, the data volumes are sufficiently high that like just the amount of data you have to store if you're timestamping all this is quite tricky. So then there's this whole software problem downstream of the switches. But we built this up over time, to the point that now the ASX has these timestamping devices in the core of their exchange, which monitors all the traffic between their leaf and spine switches. Eurex own their high precision timestamping files based on Metamako gear, and so you get high precision timestamps out of the European exchange, and and this is now everywhere. It really has pervaded everywhere in the market. There's other firms that are doing similar things and so on. But one of the things that we realized as part of building the company was that it wasn't just about the technology, but about the company behind the technology. And that was a crucial realization for me from someone else who had the insight. Our head sales guy, Kieran, he had this insight, especially when this new firm Exablaze got founded, a competing firm. He's like, don't worry, the technology is going to be good. We're going to be plus and minus on occasion, but where we're going to really shine is we're going to have high quality hardware and software. We're also going to have high quality support, and we're going to have high quality sales, and all of that, and a high quality. We're going to deliver. Our logistics are going to be better, and all of those things come. And he was absolutely right. Those things were absolutely critical over the long term. Also, building the boring features really mattered. How do you integrate these weird devices? They're so weird. They behave completely differently to every other network switch you've ever had. How do we make that as normal as possible and reduce that barrier to entry and put an enormous amount of work into making sure that this felt familiar to the people who were installing it. So building that integration piece was a huge challenge and not technically glamorous, but absolutely critical and probably one of the major reasons for our success.
5.5 years, crazy fun journey, and then you obviously get the company gets bought, or you have an exit. They talk about it in startup lands, which essentially means, like, I guess as a startup founder, when it's your company, you have like full risk and it's just like all on you. And then eventually you hope that you can either merge with someone or you can get bought by someone or some kind of, basically where someone says, we'll take over the risk of your company in some way. Here's either a payout or here's some stock or some kind of option where, like, all that hard work, there's a calm settling moment. And typically you don't have to keep working on it forever. A lot of startups that get sold or exited, you have to work there for some period, quite often, not always. But I guess it's like, without going too deep into the whole who bought you for how much or anything like that, there was a moment where you got to exit the startup, you worked out for a bit, had a period you worked out, and then after that you'd essentially kind of succeeded with the business. You didn't have to work there anymore. As someone myself, and this question's a very personal one because I'm 7 years into a startup journey, right? What's it like to suddenly have this thing that was kind of high risk, somewhat consuming, somewhat stressful, and then just realize, like, life's very different now?
Yeah, I mean, we had optimized the business for growth, so everything we were making, we were investing back in. We doubled our revenue every year for the 5 years, and I mean, it kept going somewhat after that. So it was a very successful business, and a lot of the challenges that occurred when the business was alive were to do that growth. Like, we go from being 10 people in a room, everybody knows everybody has lunch together every day, the communication's very strong. You expand it out to 60 or 70, I think we were by the end. Obviously, there's different groups of people doing different things, different cliques. The social structures within the company are quite different. Yeah. So we were very successful in growing up to that point, but the stresses had come on towards the end of at the company. My role had changed probably away from something that was optimal for my skill set. I'm probably better on the scrappy end of things than I am on the large scale managed, like
the
100
executive
people
level of things, right?
Yeah, I just want to get my hands dirty and get things done, and that doesn't always work well. Yeah. Like I said, I'm going to be learning all this forever. So life is always going to be a work in progress. So when we got to the end of it, it was we got this LinkedIn post, and we had hired a CEO who's an absolutely fantastic person, Kevin, and he just said, Dave, and there were two other co-founders, Scott and Charles, for Metamako. And he came to us and said, like, there's this, someone's just got in touch with me on LinkedIn. It's this guy from a company called Arista. And Arista is a very big data center switching company. And it's probably the biggest data center switching company, I think, by some metrics. Anyway, it sells to people like Meta and Microsoft. So they've just dropped a line like, what do you think? And we started going down. We had having the conversations. We flew out to California and did the whole bit out there. Like, it was a whirlwind. I was actually going to a wedding in Austria, and they said, we need to see you tomorrow. And so my wife and my 6-month-old daughter got left in Austria. They went back to England, and I went off to the US, and there was this whole thing. Anyway, one of the things Kevin said, and he's like, he's the wise old hound in this particular context. He said, you got to prepare yourself for this, Dave, because this is going to be incredibly emotionally trying. You're effectively handing over this thing that you've created over a long period of time to someone else, and once they've got the keys, it's theirs to do whatever they want to do with, and you're not going to agree with everything that they do, and that's going to be hard. And I think I don't know if everybody else, like, I think there's some people who are able to not, like, just sort of emotionally detach, but that's not me. It was very hard to hand over the keys to this thing that we'd been slaving over for a long time and put so much love into, and then, you know, have someone else be able to make calls. And I think it was, you know, in retrospect, I think it was the right thing to have sold it, and, you know, there was a lot of reasons why that was a good thing. But at the same time, like, an exit is a way of getting out, and you know, you give up a lot when you get out. You have a lot when you're inside the company. You have control, you have autonomy, you have the ability to get things done, and then you become part of a larger company. And I think one of the things that I really struggled with once we became part of the larger company is that we weren't the center of attention anymore. We were a small part of a very big machine, and as a result, our customers were a small part of a very big set of customers. And while we wanted to pay as much attention to them as we could, the infrastructure within the larger company, you know, it was set up to optimize for the greater good. And rightly, right?
Yeah.
So it was hard to be as good as we could be for our customers while being part of the larger
Which is hard when it's part of your identity. Like, you know,
well, especially when you're part of when you're the face of it. So I would go to customers and try to talk to them about the decisions that were getting made, and I would put I would try to, like, sugarcoat it for them. But I'm an engineer. Like, the reason I was good at sales was because I could tell, you know, people appreciated my honesty and candor, and so that became very difficult. And then, you know, so the decisions would get made that I wouldn't necessarily agree with, or it wouldn't be optimal for my customers, or wouldn't be optimal for me. And it was just quite an interesting thing. I later read The Innovator's Dilemma. I don't know if you've ever read that. It's a oldish textbook, business book about disruptive technologies within larger organizations. And it basically says, like, it's impossible as a disruptive technology, different technology with a different set of values, different business model, to really operate well within a larger organization without some level of separation and autonomy. And I think that really described us. So my experience of this, back to your question, is there are a lot of great things. I mean, Arista is a wonderful company, with some wonderful people, like truly wonderful people. And they are incredibly smart. But they're a big company doing huge things. And we were a small part of that. And we were effectively just a distraction from what they were really trying to do.
And just for, like, I guess, because I think I understand, but just for the listeners' benefit, is it fair to say there's kind of like 3 stages you've been through here? There's like pre-exit, where you were just your startup building and doing amazing
trying
things.
to do everything we can to sell, provide as much value to our customers as we possibly could.
Exactly. Then there's a second stage where someone comes to you and says, this Arista in this case, hey, we'd like to buy you. We basically want to pay you to own your company.
Mm-hmm.
And then there's a period where they don't just hand you a check and you walk out. There's this period of, 2 to 4 years, 1 to 4 years, where, like, you work for Arista and your company's there because they need to see that you're going to make sure it integrates well and that it can settle in. And then after that, you can quit and you can keep whatever they sold.
Yeah, I mean, you're not chained to your desk, but there's various financial incentives. They call them the golden handcuffs, right? You can walk away anytime, but
you might miss out on
absolutely insane to do that.
Yeah,
and that was the situation I was in for quite a period of time.
Yeah, right. So you're talking about that period, because I think it's like you had kind of sold your company in a technical sense, but you hadn't earned out the amount that.
Yeah, and one thing they often do is have an earnout. An earnout is usually where you have milestones where the company has to perform to a certain level in order to get the full value of the transaction. Whereas in our case, we just had to hang around.
You just had to be employed.
Yeah.
Yeah. I think I had friends that I had a couple of friends who ran Car Next Door, if you know that company, and they got bought out by Uber and turned into Uber Car Share, and they had a similar thing. They just told me, they were like, as long as I turn up to work and I don't slap anyone, I just have to work for some years after this.
The other complication that was thrown in there right in the middle of all this was COVID. And so at the same time as being a remote company, because headquarters is over in California, we were also now doing everything remotely with even our local team. So that made everything a little trickier also. But I think, that, and there were various ups and downs through that whole period. I mean, Arista are doing all sorts of interesting stuff, particularly in the AI networking space now.
It's all that stuff I hear about, Meta's trying to poach staff to build their big AI models. Like Arista is selling to Meta probably, or companies like Meta.
So, I mean, and this is public because they're larger than 10% of Arista's revenue. So, I mean, I don't know what they are this quarter, but they certainly sell a lot of stuff to Meta.
And companies like Arista buy companies like yours because it's just a quicker way to grow, is to be like, let's tap into something smaller rather than try and research it ourselves.
Interestingly, Arista had grown out of this whole high currency trading space. They had a lot of success with selling the Fulcrum chipset in the Arista 7150, and they'd made a lot of good relationships, and they were still kind of a premier product, and they had a lot of competition with Cisco particularly in there, where Cisco had come out with a faster product. And so they had a lot of they wanted to serve these customers as they could. And I think they realized that they could develop the capability to do what we were doing internally, and they could absolutely have done that. They've got the people that are smart enough to do it. They've got all the infrastructure for building network switches. They just had to sort of pivot on. But like we were talking about before, it's hard to do things in a larger organization. And so they saw buying us as a way to better service these finance customers that had these very specific needs. And it turns out that those specific needs are not really required in any other branch of networking, like for the most part. I mean, there's a few bits and pieces that help. And I mean, a lot of the expertise that we built up in things like field programmable gate arrays that we use to implement our switches, they can be applied to other areas, but the specific products that we were building weren't that relevant.
How many years did you work at Arista?
5 years. So I did 4 years.
That's a pretty long period, is it?
Yeah, I did 4 years, in order to get rid of those golden handcuffs. And then I did an extra year because I wanted to finish some things off, and I liked working with the people.
I love that. That's like true peak engineer in the soul, kind of. I got to finish it. And I mean, I guess then, I mean, I'm 32, and I don't think I've ever taken more than 3 days off work since I was 18. It's always been something, whether it was solar cars or whether it's a startup. Right. And it's like,
you're a pretty unique individual, though.
Thank you. And it's like, what is it like after all of that? After all those years, from optimizing solar cars to being in court, being a witness in court, should clarify that, through to like building this company, through to working out this period, and then suddenly like you don't have to work anymore. Like you're not required to work in order to survive and, raise your kids and stuff like that. Like, is it relieving? Is it boring?
I think the period I was at Arista, I felt I'd already lost the sort of purpose and drive that I had when I was at Metamako. At Metamako, I was always pushing to try to optimize things to be better.
And that was the motivating part.
Yeah. And also, I had enough autonomy and control to be able to get things done and to fix things. At Arista, I had some of that, but that dwindled, that sort of reduced over time. And so I think by the end of that period of time, I wanted to finish some things off, but at the same time, I didn't have the same sort of fire that I had when I was at the end of Metamako. So it just wasn't the same, and it was like absolutely an emotional trial, trying to readjust and find my place in a world where a lot of what I had built up and the way I had built it up wasn't true anymore. You build a company in your own image and with your own preferences, and you're at the systems that you like, and everything feels warm and fuzzy and comfortable, and then you get thrown into a different company where it's someone else's preferences.
And you have to explain that to people that trust you.
And you can argue for your own preferences, and sometimes those will be, those arguments will be valid, and sometimes not.
But you're an employee.
Like, you don't get control over this, and you sometimes don't have the ability to fix problems when you see them. And that's coming from the startup world into that of the world of a larger company. That was a hard adjustment. So I feel like when I got out, it was liberating in a way, but I probably still felt that I didn't have the sort of direction that, it wasn't some sort of panacea where everything was cocktails and sitting on a beach and all the rest of it.
Not heading to Greece and being like, let's just watch Netflix all the time.
Yeah, like, I'm sure for some people that's how it was, but like, as you can imagine, in someone like my DNA, is this isn't fun. Sitting on it was fun for a week or something, but then it's okay, right? Next job, like, let's get on it. Yeah. So I think really since then it's been much about a lot about getting over the burnout from 5 years worth of Metamako, then 5 years of Arista. And then, and really healing from that, and that's taken, I'm now 2 years past that point. So it's taken a long time to get to the point where I feel a little bit more resilient again. And I have a little bit a longer attention span. And, I'm sure for some people, they're just straight out and right back into it and super excited to throw themselves into. For me, it's taken some time, even though I really want to get into it. I haven't been able to.
I tell people one of the things I hate is in high school, they'd often say, don't work too hard this week, you might burn out. And the way they talk about burnout to kids is in this very like, you might do July and burn yourself out for August. And I think something I've realized as an adult is like the proper burnout is a way longer time scale thing. Like it's 5 years that'll burn you out. That takes, like, literally in your case, exactly like a couple of years, where in that time, like, even I've had small moments of it where like it comes out maybe in the form of procrastination or a lack of focus or,
lack of motivation.
Yeah, exactly. And you want to be motivated, but it just like, you hit a wall and you're like, I want to get over that wall. And there's just some deep
just can't
shit
get stuck.
Going on.
Yeah, exactly. And you can't work it out. And it's so frustrating. It is so frustrating because you're like, I want to get in. And particularly for me, I'm 45 now. And I'm like, I don't know, 20 or 30 years worth of really useful working life left, maybe. And I'm like, I want to get on with this. But at the same time, it's not a choice. There's something fundamental. I mean, and then layered over that is, I've got small children at the moment. And
how old are your kids?
7, 6, and 4.
That must be the best part. If you had to rank it out, I imagine at least the best part of taking, I guess, becoming financially independent, you call it, in terms of like, you don't feel like you're shackled to work in order to provide, right? That you can just take a moment and actually spend time with the kids in their critical years.
I think I'll tackle that in two different parts. One is this idea that financial independence makes you, gives you freedom. I actually think that having financial independence removes one of your North Stars and removes some level of purpose that you once had. I think you build an identity around succeeding based on this metric of financial performance, and then you go, okay, well, now it doesn't matter anymore. Now I don't have to earn any money. I don't have to go to work. And you go, well, if I'm not, and also like just getting out of employment generally and not being traditionally employed removes that level of direction that you once had, that I'm getting up and I need to go to work, and that's what I do every day.
So there's
that routine.
There's like a practical safety element that comes from it, and like there's less physical stresses. Like, for instance, if you go somewhere and you can't find parking, you're like, I'll just pay for parking because things are fine. But the flip side of that is the person who's driving that car, you, is a little, your identity is a little less clear than it was, back in the startup days where you purpose driven, everything kind of,
Well, in the startup days, you're purpose driven. You wear the startup company's t-shirt, and it becomes part of your identity. And then when you sell, you sort of have to extricate your identity from this thing that you built, and then you finish up your time. This is my experience anyway. And there's definitely an element of searching and trying to find the next thing. And I think some people are in that situation. They throw themselves into the next thing because they're ready for it. In my case, I felt I just needed to take a great big breath, and I told everybody it would be 6 months, and it's now 2 years. So I think there's various bits and pieces that I've done in the meantime that have been super fun, but I think that this is a really complicated area, and I don't know that I can describe it myself, right? I'm still experiencing this.
Yeah. We've caught up to the modern era where you're halfway through this chapter, right?
But what I would say is that having financial independence is great. It means I don't have to worry about parking if I want to. I don't have to, and for my kids, I don't need to worry about that.
If they're sick, you'll just take them to the doctor. They'll get the X-rays they need. It's not
super worried. Yeah. Super worried that so it's super good that I don't have to worry about that anymore. So it relieves that pressure. But and these are 100% first world problems. That finding the next thing and finding the same level of passion, particularly in this new era now where I have 3 kids and a family, and I've got other obligations. I can't go and work 14, 16-hour days at a startup anymore. I can't work all weekend at a startup. Like the expectations on, my idea of what is a productive day was set, in 2013, 2014, or maybe even in the solar car days where we used to work, literally 24 hours. And now I compare what I can get done today where after this, I'll go pick my kids up at school. I just dropped one off at daycare before I came here. Everything gets chopped up a lot more, and it's harder to be as productive. So I guess there's a new optimization, finding the right balance in that sort of world. And this won't last forever. There'll be a new phase, and the kids will go off to school and won't want to have anything to do with us and all the rest of it. So need to take advantage of it while it's here. But yeah, that parenting journey is a very, very difficult one. Very rewarding, but very difficult.
I'm really glad you get to spend more time with them, at least. I feel like that for a lot.
Yeah.
I mean,
I got to play Ghostbusters this morning, and that's pretty cool.
Well, I mean, I always say that to parents, but I'm also someone without kids, and I went to see my colleague and his kids the other day, and the whole time I was there, it was just chaos and them misbehaving. So it's easy to romanticize what it must be like to be, relatively young with young kids, and you're just all having fun and high-fiving and they're on your shoulders and stuff. But
this is something that is impossible to explain to anyone that hasn't had kids. Yeah. And you can explain the theory, you can say things that might help prepare people without kids for having kids, but anyone with kids will know that you can't really understand the experience. And also everybody's experience is totally different, but you can't understand those elements of the experience. And it's like you were saying before with burnout, that it's not about the 1 hour or the 2 hours with the kids. It's that you've got them 24 hours a day, 7 days a week for 18 years. And it's the low pass filter on, I guess, stress or on everything to do with them is a lot longer than the 1 hour or 2 hours. It's the 6 months or the year, and those are the sort of time periods that the phases things go in, and you never know what you're gonna get. I don't. Not that I'm any expert on this. I've only got my own experience.
It's a big fun roller coaster. I guess last question I want to ask. If you go back 1999 all the way through to 2 or 3 years ago in those final days of Arista, what, if you really had to look back on it, was just the most exciting times of them all? Was it the heyday in the startup? Was it 2009? I know they're all very different.
from university through to Arista, to the exit, until getting out of Arista, what was the most exciting time?
Yeah, what was the most exciting period, or like, year-ish of that time where things really were just felt like it was all up?
I suspect I could even probably put a year on it and say it was 2014. And it was the year I got married, and that was phenomenally exciting. It was the year that we came out with our first FPGA-based product. And, I walked down the street and literally gave like a 1RU device to someone on a street corner in Sydney. And like I said, here, go take this, put it in your data center, and off they go. Like, there was this real entrepreneurial hack and slay. Like, there was a lot of dynamism. There were a lot of problems to be solved. We had a clear mandate. We had some runway. We were starting to make sales. I was traveling overseas a lot to go and make sales to different people. I think like that year was a real highlight. And I also feel like I guess I'm a naturally competitive person, and I feel like we were, if not winning, but also, competing against. So there were these other companies that had been founded that were competing with us, and we were always everybody was always one step in front. Like, everybody would, they were leapfrogging each other the whole time. And that was just, it would seem like having the competitor would be a net minus, but actually having a competitor is awesome. Yeah. And you were inspired by your competitors. They would come out with some innovation, and we go, how the heck did they do that? And we'd sit down and go, oh yeah, we could do this. And what they were really doing is opening our eyes to the possibilities of, what was possible. There'd be a new gauntlet laid down, and every 6 months there was this cycle of conferences that we all used to go to. Someone would get up and say, I've got a 40 nanosecond aggregator, and then someone else would say, I've got a 35 nanosecond aggregator, and
everyone's going back to the office, and what are we going to do about this?
Yeah, not even back to the office. They do an email. They've got a 35 nanosecond aggregator. We've got to fix this quick. Start typing. It was super good. It was like solar car racing, where every 2 years someone turns up with a new car and they've got a new idea, and it's unlike solar car racing. Super awesome in that everybody is quite friendly, particularly after the event, and everybody wants to help each other out. And that's not quite true in finance and trading. It's a bit more of a dog eat dog, but it's a very pure playing field, like in solar car. With solar cars, it's the person that crosses the line first in Adelaide, they're the winner. Yeah. And it's sort of true with trading as well. Like, if you're making money, you're doing well. I guess that was the thing that made me shift from trading to a product-based company in the end. Yeah. Was when you're making money, your only product is money. You're not actually making anyone happy. Whereas once we started selling to all of these trading firms, and we started with the high frequency traders, like DRW, but later on moved to the stock exchange, I found that much more fulfilling and interesting. So
that's amazing. And I think for me, my takeaway with everything today, which I love, is just how there's this thread through it all. I think, like, particularly for young people I talk to, there's that phrase that's like, all the stories make sense in reverse. Exactly. And I think, like, hearing about, there you go, hearing all this today, I think it's such a good reminder for young people too, is like, not to overthink what's next, not to be like if you're working hard and you're learning and you just kind of keep tumbling forward, like your 19-year-old self wouldn't have predicted that you would end up in finance and then end up in finance electronics and even possibly electronics at some stage. And I think it all makes sense.
If you tried to connect the dots in reverse, you would, or if you're trying to connect the dots forward, you would go, well, why on earth are you working on this solar car project? This is like you're spending all your time. You need to get to your classes.
Finish your PhD. You've been doing it for 5 years.
Yeah, then you would be saying, finish your PhD. But I picked up so many skills doing my PhD. All the side projects that I had, both within my research group, because I got quite distracted with other side projects in my research group. But if I hadn't done that, I wouldn't be able to have. Then I wouldn't have met the people that I needed to meet in order to then build technology we built. If I hadn't done the operating systems PhD, I wouldn't have understood a whole ton of stuff. And maybe those dots would have been connected differently in reverse if I had, I flunked out of a interview with Google in about 2007, for example. And, maybe if I hadn't flunked it, maybe it would have been, the story would have been completely different. Maybe I would be, a cog in a machine right now. But I didn't, and that trading firm. If we had decided to not take the risk, which would have been a totally reasonable decision, if I had just decided to go get a real job at that point, it would have looked differently. But this particular set of dots, this particular set of choices leads to this point. It's pretty good.
Yeah. Well, thank you for sharing.
No worries.